and when they close, no more positive charges get into the cells. And also at this value of 35 millivolt, voltage gated potassium channels open. So at this level, there is closing of voltage gated sodium channels plus opening of voltage gated potassium channels. And potassium is more inside the cell. So when its voltage gated channels open, potassium gets outside the cells. So there is positive charges that gets outside the cell, right? So our membrane potential goes again into the negative side because there is leakage or there is positive charges that get outside the cell. So membrane potential again goes to the negative side. But it also get to lower than the resting potential. Okay, so what happened here is we are getting again to the state in which our cell was at in its resting state. So we are going again to the polarization state. So we call that what happened here repolarization. Okay, so repolarization occurs when first sodium channels voltage gated channels closes and voltage gated potassium channels open. So potassium gets outside the cell, so our cell is again repolarized into its initial state. But more positive here, more positive potassium gets outside the cell. So our membrane potential is even lower than the resting potential, which is negative 70 millivolts. It's around, we can say, negative 80 millivolts. So at this state, we are even less than the resting potentials, right? So there is more of the polarization state. We can call the state here, it is more of the polarization state of the resting state. So we call what happened from here to here hyperpolarization. Okay, it's more of the polarization of the resting state. And in this state, we are much more um, far from the threshold. Okay, now after we reach that state, potassium channel closes again and we get again into hitting the threshold after stimulus, of course, and then we have another depolarization and repolarization and so on. Okay, and this depolarization plus repolarization, we call it action potential. This is the potential which caused an action inside the cell. So for a cell to have an action, it must have depolarization followed by repolarization. So depolarization plus repolarization is called action potential. It is the potential of the action. So if your cell had depolarization followed by repolarization, it had an action. So we call this potential action potential. Okay? Now, we would move to another important thing we should know as a fundamental of the pharmacology, which is this sodium-potassium ATPase pump. What is the function of this pump? Okay, let's revise what we learned here. Depolarization occurred because the voltage-gated sodium channels opened, so sodium entered inside the cell. Okay, and repolarization occurred because potassium channels opened, so potassium gets outside the cell. But initially at resting, potassium with more inside the cell and sodium with more outside the cell. But in depolarization, sodium entered, and at repolarization, potassium get out, right? So we want to recover this state. We want again potassium more inside and sodium more outside. And this is the function or the job of sodium potassium ATPase pump. This pump gets 3 moles of sodium outside the cell and get or move 2 potassium moles inside the cell. So again, our sodium is more outside the cell and potassium is more inside the cell. And that occurs at the end of action potential. Okay, now let's move to another important topic. Let's have a look at this neuron here. Neuron is the structural unit of nerve. Okay, and we would discuss that in more details later on. But neuron consists of this part here, which is called cell body, and this part, which is called axon, and this part, which is the terminal of the neuron or the terminal of the axon. Okay, we would take that axon terminal part here and we would enlarge it. Okay, so that what you see here is that the axon terminal. Okay, and there is a cell that is innervated by this nerve. Okay, now the space between this nerve and this cell, or if this is a nerve and this is another nerve, this space which is between them is called synapse. And if there is an action in this neuron or this terminal of axon, and this action want to move to this cell through the synapse, which is the space here, this wouldn't happen easily, but it would happen through something that transmit the message or the action from the neuron to the cell. And this transmitter is called neurotransmitter. And it's called neurotransmitter because it transmits the message from the neuron to the next cell. Either this cell is a cell on an organ or it is another neuron. Okay, so this neurotransmitter is the responsible for transmitting the message or the action from the neuron to the next cell. Okay, these neurotransmitters are stored inside vesicles in the axon terminal of the neuron. But how these neurotransmitters are released from the neuron to the next cell? Let's see. When there is action in the cells, or when there is depolarization inside the cell of the neuron, when this depolarization occurs, calcium channels opens. Calcium channels open. And when calcium channels open, calcium is found more outside the cell. So it moves according to its concentration gradient from high concentration to low concentration. So calcium enters inside the cell through its channels. Okay? And calcium is responsible for two important things in any cell. If the cell is a muscle, calcium causes contraction. Okay? And if this cell is a neuron or a gland, calcium is responsible for release of the contents of this cell. So calcium would help in the release of the neurotransmitters from its vesicles. So when there is depolarization in a neuron cell, the neurotransmitters which are stored in the axon terminal, it would be released because depolarization opens calcium channels and calcium enters inside the cell of the neuron at the axon terminal, releasing the neurotransmitter in the synapse, and then this neurotransmitter act on the other cell, transmitting the message from the neuron.